Our next presenter is from Hungary. He is Zoltán Biczó, Zoli Biczó, and he will talk about auto ML, so auto machine learning. What we need to know of him is he's a senior data scientist, an AI consultant, and he is also the host of the first Hungarian data-related podcast called Adatépítész for Hungarians, but for international guests, it's Data Architecture. This is the name of the podcast. Fun fact of him that he is collecting weird data sets. You can ask questions via Slido if you wish to know what data sets are those, but it's not part of the presentation. So please welcome on stage with a warm welcome applause our next presenter, Zoli Biczó.
Thank you. Hello, everyone. So first off, thank you very much for being here instead of queuing up for the lunch, as most of you. So that's great. All right, let's try to start. Okay, cool. So, as you might have guessed, the main topic today is artificial intelligence, because it's a PowerPoint. So if you need to do something, obviously it's going to be Python, but it's PowerPoint, so it's AI now and not machine learning. But you get the point. So probably on the topic of AI, you've heard numerous presentations that might have changed your view of the world. Now, this one is not that kind of presentation. I don't want to change your viewpoint of your life and anything like that, but it might change the way you work on an AI project, on a machine learning project. So that's my aim here, to give you some insights on how we work, because I think we did develop a method that is very efficient, and it's quite easy to replicate, and it's not patent pending, and you don't have to pay for it, so kind of cool. So, how we used to work. Okay, I know I haven't given you so far anything of value, so I'm not going to waste your time about my company name and anything like that. That will come at the end of the presentation. Hopefully you will be interested. But we are a small company building data products, as I call it. So sometimes machine learning, sometimes advanced analytics, most of the times machine learning for our customers. That's enough for right now. So a usual project has a team of 2 or 5, maybe, usually. It's in projects, so in small chunks, obviously. And traditionally, it was like any other software development project. And the traditional waterfall stuff works. It's not that bad. Eventually, it works. It has some problems. We know that, but you know. Ideally, these projects are business-backed. So it's coming from either marketing or the CEO or someone who deals with the stuff that the company deals with. More often than not, it's IT-backed in practice, because AI is a little bit complex, or seemingly complex, and C-level people tend to give it to the technical people and deal with it. It's computer stuff. That's not ideal, but that's what usually happens. At least that's my experience. Maybe yours is different. And this is a little bit unrelated, a little bit personal. So I have a little son, and this week he had his first judo lesson. And the first thing he learned, obviously I was asking what he learned, is how to fall. And that obviously makes sense. Why do we learn that in judo? Because he's gonna fall a lot, obviously. So it got me thinking that it's actually a really good idea. And that's what I also do in my projects. I mean, not literally, but almost. So what is the traditional machine learning development? I think you all know at least some of these, right? These are different methodologies aimed more or less on data-related development, not necessarily machine learning development, but data-related things, so data mining, whatever you want to call it, the same stuff. I know, not the same stuff. So, there are a bunch of them. And they're not bad, they're good, so I don't want to say it. As far as I know, most of us use the CRISP. Show of hands, you know this, right? So I don't have to, or at least heard of it. Show of hands, please. Half of you. The other half is half asleep, so I would say most of you have heard at least. It's a good stuff. It's good stuff. We used it. Fine. How does a machine learning project look like? It looks like that you up numerous times because you around and find out. That's how it works, right? All of these methodologies are basically saying the same thing, just in a more eloquent way. So then I figured the faster you can fail, obviously not I'm the only one who figured this out, the faster you can fail is the faster you can succeed, because you weed out your bad ideas, basically, that's what I'm saying, right? It sounds strange, it sounds a little bit like, you know, these feel-good type of presentations. You just have to believe in yourself. Not really, that's not the case, but if you weed out your bad ideas, bad data sets, bad methods, bad algorithms, very, very fast, then you end up with the good ones very, very fast. Simple as that. So, fail fast and carry on. What does this all have to do with AutoML? I'll tell you in a few minutes. So, machine learning process, or doing projects, whatever you want to call it, is still partially research. You don't exactly know when you start it, you don't even know when you can even do it. Not because you're not confident or you don't have the skills and the tool set and everything. You might not, it might not be possible even. That's a possibility. I know nobody wants to hear it, so no business wants to hear that. That's a great idea. The only downside is it's not possible. But sometimes that's the case. So most companies nowadays, even the big ones, okay, maybe not Google or maybe not Microsoft, but most companies, even the Fortune 500 companies, are on the early stage of developing and adapting AI products. Therefore, it is still more or less an R&D, no matter what anyone tells you, right? So, there is a comparatively large market hype. Like you literally cannot read any magazine or anything without the mentioning of AI, right? So there's a huge hype. But on the other hand, the actual literacy of the whole stuff is pretty low, right? So this creates an interesting environment. A lot of people heard about it. Very little is the amount of people, very small is the amount of people who actually has the slightest idea of it. Most data sets are not purpose-built. So I know that you heard numerous times that companies have and create and generate enormous amount of data, and that is true. However, most of it is garbage, and that's also true. So you need tooling, you need processes to make it useful. It's not purpose-built data, so that's an issue. Most IT departments are agile. I have to admit, a lot less of you is smiling right now than I would expected that. So, at least in theory, meaning that the development teams or organization, whatever you want to call it, is more or less agile or using agile tools and methods or have been on a training about agile or something like that. So if you want to work with them, and you have to, unless you're a startup or something, or you're developing your own stuff, but if you want to work with them, you need to somehow be at least partially compatible with them, right? Because you cannot go to your customer and say, okay, everything you do is, and we're going to show you how to do this. This is maybe not the best way to start stuff. So, and yes, this is an interesting phenomenon that we have, that AI to do, machine learning to do, is fairly complex, involves fairly complex math, or at least a lot of math, which is not that complex, but you know what I'm saying. Although, to actually understand what it does in reality, if you do it right, it's very simple. What I mean is, when you open Facebook, your news feed, or you open YouTube, right? it's fairly simple to understand that the stuff that you see immediately, the first, I don't know, 20 videos, 20 clips, whatever, has been chosen by AI or some kind of machine learning algorithm for you, and because of your whatever, your history, what you watched, and all your data about you. It's easy to understand, right? Computer tries to know you, and based on that knowledge, recommends you good stuff. It's easy to understand, very easy to use, very easy to grasp the main idea, although to implement something like that is fairly complex. So this is an interesting dichotomy there. So ideally, we have defined, well-defined goals like we need to do at the very beginning of the project. We know the resources, at least, data sets, people, tools, whatever. They are all allocated. That's also important. So we have a good general understanding, right? In practice, that's very often not the case. We don't have a clear business goal usually. We have a business idea, maybe a wish, not necessarily a goal. So we have this process, or we have this way of operation. We want to make it better, because wouldn't it be great if this and this and this decision would be aided by AI, and magic happens. Most of the time, that's the business goal, more or less. Maybe it's longer than what I just said, but that's the meaning of it, you know. First step, second step, magic happens, profit. So that's, you know. So we have a general idea of what AI should do, but it's also sometimes not very clear. So AI needs to make some kind of decision in order to be better. But based on what, how to decide it, it's not always clear. So all in all, it's always a high uncertainty project. There's a lot of stuff you don't know when you start, right? What can you do about it? Well, not much. That's the case, right? So you won't change the world. What you can do, though, is to mitigate this uncertainty, these risks. So what you can do is to fast fail. So to find those points that makes impossible to do this, the very uncertain things, and if you can overcome those, then you're set. Then you have that ideal situation which you usually don't have, right? So we need to apply agile ideas, or at least be compatible with them, more or less, in order to work with the company. Yes, we need to create working prototypes en masse, right? So there is a lot of uncertainty, meaning we're gonna fail numerous times. Our first 10 models gonna be trash, the second 10 gonna be somewhat not trash, and maybe the, I don't know, 27th would be okay. Because it's a process that you need to do. There is no magic wand. You cannot escape this process. That's how it works, right? The only thing you can do is to make this process really fast. And this process is time and resource consuming, so that's a problem. Because you have like 11 machine learning engineers, it's gonna be pretty fast. But usually you don't have 11 of those because it's very expensive. And of course, since it's a development project, you need to be at least somewhat reportable and clean, code-wise, I mean. Otherwise as well, but that's not the topic today. And you need to clearly communicate your results. So at least in my experience, you cannot go to the business person and tell you about your F1 scores, because that's not going to be successful. He won't be able to understand you, not because he's stupid, but because his mindset is on a business process and you're talking about statistics. It's just two different words. Right. So what is AutoML? Show of hands. You know what that is, by the way? Because if you do, we can skip. Only one of you. Oh, okay, a few of you, but most of you know. Okay, so it's basically, it is a software framework, some kind of software tool, which automates a lot of the data science process. Meaning, you don't hand crank your models. You don't tune your hyperparameters by hand, or at least 90% of the time you don't. Instead, there is some kind of search, maybe just a very simple grid search or a set of possible and viable values, maybe. Sometimes it's a bit more complex, but you don't have to do that. And the computer does that for you. So it basically generates numerous models, maybe hundreds, maybe thousands of them, scores them, and weeds out for you. Because basically, it's faster than the way I would do it, because it's a computer, right? It does have some downsides. I will talk about that as well. So it's not all nice and shiny, but it helps a lot. Because it reduces costs, reduces time. I don't have to tell you this because, I think by this point you understand what I'm aiming at. There are actually a ton of auto machine learning frameworks. I highlighted H2O because I hate mysteries. I hate creating mysteries. I know it's marketing-wise lucrative, but I still hate it. That's what we use on the reason that that's what we started to work with, and it works. No other reason. So I'm not really endorsing any of these. It's a bunch of those. All of those basically does the same stuff, more or less. So they are different, but they're the same, right? So it's not interesting, actually. There's a bunch of tools you can do it in any of those. Some of them are paid, but not very expensive, to be honest. Some of them are free, up to you. All right, about the agile compatibility. So how can you use this? Well, the actual real agile methodology is different, actually. It is an iterative process as the same as CRISP, same as usually data science is, but it's still different. But mostly, it's different in its language, in its liturgy, as I would put it. So the stuff that you can see from outside. But the basic ideas are very similar. Iterative process, producing the biggest business outcome as fast as you can in each step, sorry. So you can actually intertwine this. And AutoML also helps in this regard, because it enables you very fast iterations, very, very fast iterations, therefore enables you to kill uncertainty as fast as you can. It's not instantaneous, it's not magic, but it's a very fast way to reach that not so scary point where it's not so uncertain anymore, right? And basically, that's very, very, it's not the similar, but very, very similar to what Agile says, more or less. If there's an Agile coach here and is already crying, I understand you, but still I'm right. So, you must do the first things that are the scariest, right? So basically, these are the first three things that you must do in any machine learning project, because if all of these three are okay, then your project is 90% A-okay, right? So there is basically no point to do data wrangling and all these kind of things for weeks, and then figuring out that the initial data set is useless, basically. So you created 1,100 dimensions of it, because you're smart, but for no avail, right? So, first, is it the original product idea even viable? It sounds scary, because it means that if the answer for that is no, it might kill your project. That's true. If you are, in my experience, if you are very transparent, very professional about this, and you know what you're doing, and you put this on the table before everything starts, at this point, about 50% of the time, not all the time, about half of the time, you can convince your customer to do something else with you. So you're not totally screwed. Half of the time, you're screwed, but that's just life, right? So this is very important. It's a crucial point. The second biggest problem in any machine learning project is usually the data set. So companies have a lot of data. Most of them is garbage. As I told you, I think all of you heard garbage in, garbage out. That still holds, that's true. And sometimes that's just the case. And at this point, you still have a lot of options. You can have, or maybe even buy additional data. You can realize, and maybe, sometimes that works, not all the time, sometimes that works. You can convince your customer that he needs to do something, a little side project, so to speak, with their data. That only happens if the data is so bad that you realize that other processes not involving your project is also probably faulty, they just haven't realized it yet. Then you're to go. If it's only needed for your project, you know, you're probably dead. But that's the truth. You wasted maybe 3 days. Okay, that's bad, but probably not 3 months, which is, you know, even worse. So, you know. And another very important thing, because of the hype, because of the enormous and, quite frankly, sometimes not very professional marketing behind AI, a lot of people expect basically miracles, right? So I was involved in a project where our initial models, the accuracy was usually more than 90%. And I was kind of proud of myself, to be honest. Oh, that was a total failure, because then we realized that 90% sounds really good, but in the engineering world, not software engineering, the actual, you know, metallurgy and stuff, they create actual physical stuff, which is, by the way, much harder than IT, to be honest. I can say this because I'm in IT, so, you know, it's much harder. The precision that they wanted was 99 point something, and they already had 98 point something, and they wanted to up that to 99 point something. And the seemingly small gap that we have there, that 10%, was totally impossible to reach. And I was initially confident, because I mean, 90%, a little bit more than 90% accuracy. I was even a little bit afraid that we, you know, we have some overfitting issues, because it was so great. That was I was thinking. It was basically useless. And from the amount of data that they had, statistically, it was impossible to get better results. So there you have it. I know I'm talking about failures, which is strange, because most people talk about great stuff, but actually failing here is great stuff, because you're avoiding costs. And in my experience, if you're failing, so to speak, forward, saving your face, being totally transparent, talk about this whole process before you start the project. Obviously, afterwards it's but if you do it before it will give you a lot of credit as a professional and as a businessman. It's harder to sell this way, I admit, much harder than selling, you know, snake oil, but on the long term, you know what I mean. All of our customers, as of this moment, are customers from the past 10 years. Sorry, except one. We have a new one, but you know what I mean, right? So, is AutoML the solution to all of the problems I just said? Of course not. No, obviously not. The uncertainty of the projects are still there. You don't get rid of those. All the problems are still there, but if you do this type of that's what I call prototyping stage. So basically, really, really fast, you try to build something that works, and during that process, you can verify whether it makes sense, whether you have the data, and whether the results are actually even slightly close to what business had in mind. And if you can do this really, really fast, that's a very good thing. So basically, at the end of this prototyping stage, when you're using AutoML for this purpose, you will have a very good understanding of the business, because in order to do a working prototype, you also need to understand the business process or the anything that the business does, at least on a medium, maybe junior or media level. So you actually need to understand what guys are building, because if you only take a look at the data, I think that's very risky. And it's good for you, and it's good for sales, by the way. You will have a very deep understanding of the data set. That also helps, because 80% of the resource, money and time-wise as well, is usually spent on data in a project like this. So data wrangling, pre-processing, missing data, outliers, all these things, right? So not on the algorithms, usually. You have a good estimation, just an estimation, but a good estimation on what you can actually achieve, all in all. So what's going to be the performance of the model? Because sometimes it's not good enough. Sometimes it's so good, that happened once, but that happened once. It was so good that it generated more projects, because even business was surprised. Usually business is not surprised with good, because it's the expectation, but you know what I mean. And you have a good understanding if you require something more. Because maybe you remember, maybe you not, about 10 minutes ago I told you that there is uncertainty of the skills, expertise, and tools what you need. Because before you create your first prototype, you're not going to know whether it's going to be a neural network or an LSTM or something. You might need a specialized guy for that, or it's going to be a logistic regression. You don't know that at that point. You don't know that it's going to be plain Python, or you need someone with C, because it will run on a plastic pellet machine, maybe, and Python won't run on those. And all these kind of things. You don't know that at the start. You cannot possibly know that. So your estimations, both price, resource, time, at the end of the project, at the beginning of the project can be, yeah. At this stage, you know what you don't know, right? At least. You know what you know, obviously, and you know what you don't know, which is a very powerful thing to have, at least in my opinion. And obviously, it's a good tool if you need to create a new estimation or a new price or something, because at this point, if you realize that it's not going to be 2 weeks, it's going to be 2 years, I mean, you need to do something about that. But at this point, you would know. You wouldn't feel. You would not rely on your expertise. These are good things, but I mean, you would know. It's a huge difference between feeling and knowing in this case. Well, all cases. There are some downsides. So you have to pay a price for this kind of stuff. One downside is that not almost all auto frameworks support a limited number of models. These are the usual suspects, right? So logistic regression, linear regression, some very primitive form of neural networks, maybe 2 hidden layers, simple backpropagation, no LSTM, no nothing like of this sort. No generative models, at least right now, so none of these things. Simple decision tree, maybe a boosted tree, maybe a gradient boosted tree, something like that, SVM. So you're the usual suspects, but also Pareto rule still applies. So 80% of the problems can be solved with the top 20% of these algorithms. So I've yet to find a problem that cannot be solved with these, I would say, usual machine learning algorithms. And you need to develop something on your own, very specialized for an actual applied in the real life problem. It's different when you're in academia, of course, obviously. But you're actually standing next to a milling machine. It's usually not a new type of mathematics that it's needed, right? So there is no real possibility for some kind of state-of-the-art model to be developed. Because it's automated, it's not fine-tuned, there is 0 novel ideas in it. Because it's done by a script, right? Why is it a problem? Because most of us probably not aiming for a new software algorithm? Well, as someone who leads his own business, it's a people management problem. So you have these sometimes young developers who wants to do interesting stuff, right? And you say, you know, do the usual 10. It's very efficient, very good for the business. You can create value with that. These points I just said are true and fine. It's exciting for me. Sometimes, well, most of the times, not exciting for a junior developer, sometimes not even exciting for a senior developer. A super senior developer is fine, because to be a super senior developer, you would already understand that what you're creating, and it's usually not a new mathematical formula. Sometimes it's hard from a people management perspective, right? You still need experience and knowledge. So it's not like, give me all your data, we put it to the computer, and computer will tell us what to do. I have read this kind of marketing BS. I don't know how many times, like I think it's over 100. That's not how it works. So you cannot, save on expertise on machine learning engineers, data scientists. You can't. I mean, you can in terms of number of working hours, maybe, but it's not how it works. So you cannot just dump data on the computer and wait for the results. It still needs the experience, especially in pre-processing. And it's very important because these kind of tools are very, and I mean very effing sensitive for data pre-processing. Actually, data pre-processing, wrangling, no matter how you want to call it, you know what I'm talking about, can break or make these kind of projects. So for some people, this may take out of the fun from the game. It might be a problem. For me, no, because my fun is to build a working prototype. But every people is different, so every person is different, so just take in mind. I just brought you a case study, so to speak, from a real project, because I wanted to show you what I'm talking about, right? So it's the best way. So the reason why I was talking a lot about these actual building physical product stuff, because I already knew that that's what I'm going to show you. So it's a 3D printing something, but not the usual create me a new Yoda figure stuff. It's a metal 3D printing in industry, right? So metallic, actual metal stuff that goes into other stuff. You can see already right now that I'm an enormously good engineer. These were basically washers, right? So these some kind of metal rings. And when they're printing this stuff, when it cools down, it has some distortions because of cooling down and, yeah, I don't, but physics involved and stuff. So the goal was to create a machine learning model that can estimate very accurately these distortions so that engineers who design these metal things can compensate. So they can have a slightly larger diameter because it will shrink and all this kind of stuff, right? And there are tools for this already in the market, simulation tools. So is because in theory you can actually calculate this because physics and metallurgy and all this stuff. In practice you can't do that really because it would take forever. So there are estimates and simulations for this kind of stuff. These tools are very expensive, that's one thing, and extremely very slow. So this would take weeks. Therefore, it's usually not used. So something is created, and if it's bad, they redesign it because it's still cheaper to wait for 3 weeks. Because the market won't wait for you 3 weeks. So they have a kind of sort of solution which doesn't work. We wanted to build something that works and at least as good as the kind of sort of solution that doesn't really work. Which sounds very easy, but it's not. The data we had is the telemetry data from these 3D printing machines. So, heat and vibration and pressure and all these kind of things that I don't know about. And of course, obviously, the dimensions of the product. So the diameter, the weight, the whatever. What we did is we almost immediately realized, hands-free, that's important because otherwise, I mean, anybody from here would realize that eventually. but we did it hands-free, human hands-free, that only a few product parameters are interesting, actually. And it's more interesting to look at the actual printer itself, which, at least for me, was surprising. We very, very quickly find an effective feature set with some basic feature engineering. Was this the best that we can achieve? Probably not. Was it enough never to touch it again? Yes. We realized that from 7 different algorithm families, think decision trees, you know, I was talking about these things, only boosted tree, which actually works. We had a few minutes ride with neural networks, but you can read the slides, so that didn't really work performance-wise, cost to performance-wise, I would say. So we established that the goal is obtainable very, very fast, and the results we have is useful for the actual engineers. So at this point, you could say, so what? Right? So far, this is a fairly standard data science project. Everybody does that. And you're right. You're right. The so what part is that we did all these within 3 days. And 2 of those 3 days was spent on understanding the data, understanding a little bit this 3D printing stuff, because I'm totally stupid about that. So I needed some time to at least understand what's happening. And basically what I just said, 90% of this was done one day. And this is enormously effective. And not because I'm a very smart guy, but because computer did it for us. So at the end of those 3 days, we had a very efficient prototype. It was already working. It was ready to be deployed. It was not the best. We still worked a little bit after that with human skills, not with AutoML. But we would be able to deploy it if we wanted to. It wouldn't be that good, but it would meet the requirements, at least minimally. So we don't need to waste our time to hyperparameter tuning. We didn't figure out how many leaves the decision tree needs, how deep should it be, what should be the Gini index when we split, and all these things. We never even touched those. So it is still very fun, at least for me, to come up with a working prototype in 3 days, which is almost ready to be shipped. We won't ship it, mind you, so this is still not a magic box. But I think it's very close to it. So, yes, that's me. We are this company. We also have a podcast, mind you, in Hungarian language. You can reach me if you want to. And I have about 8 minutes. I wanted to have 10, but whatever. If you are not extremely very hungry, which I am, but you know, here we are, I'm very open and encourage you for questions. I know this is not going to change the world, but trust me, try this. Any questions?
Okay, applause, please.